Hello and welcome back. Till now we learn about how to multiply two vectors or the inner product of vectors in a vector space Rn, Euclidean space Rn. Today we are going to apply the concept of inner product to define sets. So let me write the definitions. So here we have the definition. So a set of vectors in a Euclidean space Rn. So a set of vectors. So for example, I am taking the vectors alpha 1, alpha 2, and alpha k. So a set of vectors in Rn is said to be orthogonal so the set is said to be orthogonal. We know about when two vectors are orthogonal to each other. Here we are talking about set. A set of vectors in Rn is said to be orthogonal if alpha I with standard inner product alpha j gives us 0 whenever if I not equals to j. So if we take, which means if I take two different vectors from this set, then the inner product of that two vectors. So let me write down two different vectors. So if I choose, if we choose two different vectors, so we choose a pair of different vectors. So choose two different vectors from the set, then the two vectors, then the inner product of that two vectors, then the standard inner product. So here we are talking about standard inner product in Rn. So inner product of two vectors, that two vectors is equals to 0, is 0. That's the thing. When if I choose any two different vectors from this set, if their multiplications gives is 0, then the set is called an orthogonal set. Let me quickly give you an example of an orthogonal set. So here we have an example we are talking about. Let me take a vector in R3. So I am taking a set which contain the vectors 1, 2, 2. So let me choose the second one, which is basically 2. This will be minus 2 and 1, and third one is 2, 1, minus 2. So this you can see that each vector has three components. So these are the vectors in R3. So this is a set in R3. Now we're going to check is this set orthogonal set or not. How to check that this set is orthogonal or not? What we have to do, we have to choose different vectors, two different vectors. So first of all, let me choose alpha. So this is, let me talk about, this is alpha 1, this is alpha 2, and this is alpha 3. So the statement says that if I multiply alpha I with alpha j, it gives us 0 if I not equals to j. That's the only thing you have to check. So let me multiply alpha 1 with alpha 2. What we get? We get 1, 2, 2 dot 2 minus 2, 1. So because we know that is component wise multiplication, standard inner product is component wise multiplication. So it will be 1 into 2 plus 2 into minus 2 plus 2 into 1. So this gives us 4 plus minus 4, which is 0. You can see that alpha 1 alpha 2 are orthogonal to each other, and we know that the the inner product is commutative, so basically alpha 2 dot alpha 1 also is same as, this is same as alpha 1 alpha 2, so this is gives 0. So remember that the standard inner product or any inner product, so we are talking about the standard, so standard inner product in Rn are commutative. So this so let me talk about what happen if I multiply alpha 1 with alpha 3. So here we have 1 2 2 multiply with 2 1 minus 2, so we get component wise multiplication, so 1 plus 1 into 2, 2 into 1 plus 2 into minus 2, so you can again see that this is 4 minus 4 and gives 0. So alpha 1 and alpha 3 also orthogonal to each other. So because the inner product is commutative, so alpha 3 dot alpha 1 is same as alpha 1 alpha 3, and this gives us 0. Now the left only one left is alpha 2 multiply with alpha 3. So let me quickly erase this part and multiply alpha 2 and alpha 3. Okay, so here we go. So let me take alpha 2 and alpha 3. So alpha 2 multiply with alpha 3. So alpha 2 is 2 minus 2 1 dot alpha 3 is 2 1 minus 2. So this gives us 2 into 2 minus 2 into 1 plus 1 into minus 2. So you can multiply, it gives us 4. Here we get minus 2 minus 2 and total we get 0. So you can see that alpha 2 and alpha 2 are also orthogonal to each other. So each elements in these vectors in these sets are orthogonal to each other, or in other words to say that if I take alpha and alpha j where I not equals to j, then if I take inter product between the vectors, it gives us the real number 0. So I think you understand the what is called the orthogonal set of vectors. Okay, let me talk about the sets which is not orthogonal, but this here. So let me give you quickly give you an example where the set is not an orthogonal set. So here we go. Let me take example of not an orthogonal set. So here we have taken the vectors again 2 2 1, and here we have taken so suppose we minus 2 and 1 2, and here we have 1 3 minus 1. So let's check, is this orthogonal set? So this is a set in Rn. So is this an orthogonal set or not? So first of all, let me assume that. So quickly assume that. So this is our alpha 1, this is our alpha 2, and here we have alpha 3. So you can take more than 3 vectors or less than 3 vectors. I just only take the over here the 3 vectors. It is not mandatory that for R3 you always have to choose the 3 numbers of vectors in this sets. You can choose more than 3 vectors, so or you can choose less than 3 vectors. So here we have only 3 vectors in this set. This is a set in R3. So what happen if I multiply alpha 1 with alpha 2? We get 2 2 1 multiply with minus 2 1 2. So this gives us 2 into minus 2 plus 2 into 1 plus 1 into 2, which gives us minus 4 plus 4, and you can see that these two vector alpha and alpha 2 are orthogonal to each other. So let me check that alpha 2 with alpha 3, or just to take anything over here. So minus 2 1 2 multiply with 1 3 minus 1. So let me check what happened over there. Minus 2 into 1 plus 1 into 3 plus 2 into minus 1. So you can see that here we get minus 2 plus 3 minus 2, and this is equals to minus 1, which is not equals to 0. So we get 2 vectors from this set. If I take the inner product of that 2 vector which is not equals to 0, So the definition was for each elements, each different pair of elements from the sets, if each alpha j alpha I not equals to j, over here have to be 0, but here we get an elements alpha 2 and alpha 3 where their product is not equals to 0. So this set is not an orthogonal set. So this is not an orthogonal set. So I think you understand the concept of orthogonal set. Okay, let me give you the next concept or next definition of orthonormal sets. So here we have the definitions. So definition of orthonormal sets. So a set of vectors, I just take vectors alpha 1, alpha 2, alpha k, so this is a set of vectors in some Euclidean space Rn. A set of vectors in Rn is said to be orthonormal, is said to be orthonormal if alpha I with alpha j, the same thing, alpha I with alpha j gives 0, if I not equals to j, whenever I not equals to j, we get alpha I multiply with alpha j equals to 0. You can see that this was the conditions for orthogonal set. So but here we have one more extra condition. So this is the condition 1, and another we have condition 2. It says that if I multiply alpha I with alpha I, if I multiply alpha I with alpha I, we get the vectors 1. So this is the second conditions. So when I equals to j, or just let me write I equals to j or I equals into I, so then on that case this gives us 1. So then the set is called an orthonormal set. So orthonormal sets is is a combination of two concepts. So orthonormal set equals to, we can write orthogonal set, orthogonal set. So orthonormal set is an orthogonal set plus each vector is an unit vector. You can see that this is the concept of unit vector, plus each vectors on the set, each vectors on the sets, each vectors are unit vectors. So are unit vectors. So if these two are equal, so if this concept are equal, is orthogonal plus each vectors is an unit vector, then the set is called an orthonormal set. So let me quickly give you an example of an orthonormal set. So here we have an example of orthonormal set. So in our last example, what we have the set of vectors. We already seen that the set 1 to 2 and 2 minus 2 1 and 2 1 minus 2 in R3. We have already seen that this set is an orthogonal set, is an orthogonal set. But what happen if I multiply the vectors with itself? So this is our vector. So this was our vector. So first one is the alpha 1, the second vector we choose that this is our alpha 2, and third vector we assume that this is alpha 3. So we have to multiply alpha 1 with alpha 1. So let's see what we have. So 1 to 2 multiply with 1 to 2. So if I multiply, so we get 1 plus 2 into 2 plus 1 into 1 plus 2 into 2 plus 2 into 2. So you can see that this equals to 4 plus 4 is 8, and this gives 9, which is not equals to 1. So clearly this set is an orthogonal set but not an orthonormal set. So now can I make this orthogonal set to an orthonormal set? Yes, we can. So what we have to do, we have to take the unit vectors in the direction of the vector alpha 1. We have to take the unit vector in the direction of the vector alpha 2. We have to take the unit vector in the direction of the vector alpha 3. So what we have to do, we have to take the unit vector. So how to take the unit vector? Unit vector. So vector. So let me assume that beta 1 is an unit vector. So quickly erase this part, and here we go. So let me write that quickly. So for example, suppose beta 1 is the unit vector in the direction of alpha 1, the direction of the vectors alpha 1. So how to find a unit vector? I think you know that we have to multiply just alpha 1 by this is the unit vectors in the direction of the vector beta 1. So what we have to do, so alpha 1 is, you can see that alpha 1 is 1 2 2. So what about the norm of alpha 1? Norm of alpha 1 is basically square root of alpha 1 with alpha 1. So you can see that we have already find out the alpha 1 multiplied with alpha 1 is 9. So we put the 9 over here. So this is 3. So what we have to do, we have to divided by 3. So we get the vectors 1 by 3, 2 by 3 and 2 by 3. So this is the unit vector in the direction of the vector alpha 1. So let's choose the vectors alpha beta 2 in the direction of the vectors alpha 1. So quickly let me write over here the unit vector over here is, we get 1 by 3, 2 by 3 and 2 by 3. So this is the unit vectors in the direction of this vector alpha 1. So let me quickly find out the alpha beta 2, which is the unit vectors. So first of all, let me erase this part. So I just give you a trick to find a unit vector very quickly. So here you have to do in this way, you can find a unit vector very quickly. So here is the trick, what you have to do. So here is the beta 2 is the unit vector in the direction of the vector alpha 2. What we have to do, we have to just write in this way. So write the vector 2 and divided this vector by the square of each component. So it will be 2 square. So this is the trick to find a unit vector, 2 square minus 2 whole square plus 1 square, comma 2 by again divided by same quantity, which is 2 square minus 2 whole square plus 1 square, comma 1 by. So you can see that what is the elements in the square, they are the components. 1 for 2 we get 2 square, for minus 2 we get minus 2 square, for 1 we get 1 square. So in this way, so it will be 1 by 2 square minus 2 whole square plus 1 square. So this is the quick way to do this. So what is we get? 4 plus 4 8 plus 3 is 9. So we get 2 by 3 again. So minus 2 by 3 and here we get 1 by 3. So this is the unit vector in the direction of the vector alpha 2. And what we have to do, we have just tried to find an orthonormal set from the set or from an orthogonal set. This is the way to find an orthonormal set from an orthogonal set. So also we will find the example. Obviously we will going to find an example of an orthonormal sets. So over here, so beta 3 is the unit vector. So let me write beta 3 be the unit vector in the direction of the vector alpha 3. So what we get, again we just write the 2 by divided it by the quantity over here. So here we go. So we get quickly, we get, I think we have out of page, but let me write. So if I just take the quantity over here, so I just so let me erase this part, otherwise it's I have to write over here. First of all, let me write over here, otherwise we will forget. So beta 2 is 2 by 3 minus 2 by 3 and 1 by 3 over here. So let me quickly erase this part, and find the unit vectors in the direction of the vectors alpha 3. So I'm sorry I have to waste your time for this, but I have to do this. Okay, so here we go. So let me quickly write that down. So we are just talking about the beta 3, which is the unit vector in the direction of alpha 3, which is basically we have 2 by square root of 2 square plus 1 square plus minus 2 whole square. How we get that? This one. So for this first component we get 2 square, for the second component we get 1 square, for the third component we get minus 2 square, comma 1 by the same quantity 2 square plus 1 square minus 2 square, comma minus 2 by 2 square plus 1 square plus minus 1 square. From there what we get, so this quantity is basically 4 plus 1 5 and 4, so 9. So again we get 3 over here, so it's 2 by 3, 1 by 3 and minus 2 by 3. So here the 3 unit vectors. So beta 1 is an unit vector in the direction of the vector alpha 1, beta 2 is an unit vector in the direction of the vector alpha 2, and obviously beta 3 is an unit vector in the direction of the vector alpha 3. So we get a set of vectors. So let me write down the set. So from this example we get a set, basically we get a set A which contain the beta 1, beta 2 and beta 3. Let me check this set is an orthonormal set or not. So from this orthogonal set of vectors we find a set. Let me check this set is an orthonormal set or not. So first of all let me erase this part. So here we have the set A, which is I think I remember the part. So it was 1 by 3, 2 by 3, 2 by 3. So that was our beta 1. The second quantity was 2 by 3 and minus 2 by 3, and it is 1 by 3. And third quantity was I think it was 2 by 3 and 1 by 3 and minus 2 by 3. So these are our vectors. This is a set of vectors in R3. So that was our beta 1, that is our beta 2, and it is our beta 3. So let me quickly multiply beta 1 with, so beta 1 with beta 2. So what we have, if I multiply beta 1 with beta 2, so here we have beta 1 is 1 by 3, 2 by 3 and 2 by 3 multiply with 2 by 3 minus 2 by 3 and 1 by 3. So from there we get 1 by 3 into 2 by 3. So this is a component wise multiplication. So 2 by 3 minus 2 by 3 and 2 by 3 into 1 by 3. So you can see that from there we get 2 plus 2 is a 4 by 3, 4 by 9, and here we get 4 by 9, so this gives us 0. So I just do not repeat this whole thing again. So you can just calculate, you can calculate beta 2, beta 3 and beta 1, beta 3, all you get, all are going to be equals to 0. This is the routine task to check that all of the vectors over here are orthogonal. So let me quickly give you the flavor that this is an orthonormal. This is actually an orthonormal set. So for that, what we have to do, we have to multiply beta 1 with beta 1, beta 2 with beta 2, beta 3 with beta 3. So here we go. So this is the procedure to find an orthonormal set from a orthogonal set of vectors. So quickly multiply beta 1 with beta 1, what we have. So beta 1 is 1 by 3, 2 by 3, 2 by 3 into 1 by 3, 2 by 3, and this is 2 by 3. So this is component wise multiplication, so it gives us 1 by 3 into 1 by 3 plus 2 by 3 into 2 by 3 plus again 2 by 3 into 2 by 3. So what we get, so in the 9 over here, so from there 1 plus 4 plus 4, so we get now 1. You can see that the beta 1 into beta 1 is 1, so first condition is okay. So let's check about beta 2 multiply with beta 2. So here we get 2 by 3 minus 2 by 3, 1 by 3 multiply with 2 by 3 comma minus 2 by 3 comma 1 by 3. So from there what we get, 2 by 3 multiply with 2 by 3 plus minus 2 by 3 multiply with minus 2 by 3 plus 1 by 3 into 1 by 3. So this gives us 9 by 4 minus 4 minus plus, this will be plus 1, and this is, so you can see 9 by 9 is again 1. So beta 2 into beta 2 is 1 again. So let me check beta 3 into beta 3. So what happened? So let me check what we have after multiply beta 3 with beta 3. So let me quickly erase this part. So here we have beta 3 is beta 3 multiply with beta 3, so we get 2 by 3, 1 by 3 comma minus 2 by 3. You can clearly see that is again 2 by 3, 1 by 3 minus 2 by 3. So this gives us basically 4 by 9 plus 1 by 9 plus again 4 by 9. So this again gives us 1. So you can see that over these sets we have beta I dot beta j equals to 0 if I not equals to j, and beta I multiply with beta I equals to 1. So this set A, the A is an orthonormal set. So A is an orthonormal set, normal set in R3. So in this way you can quickly find from an orthogonal set on orthonormal sets. So I think you understand the concept of orthogonal set and orthonormal set and how to find an orthogonal set from an orthonormal set. So thank you for watching. In next video we talk about how to work with this set, the application of these sets, why this set actually important to us. So thank you. Please come back in my next video.